Okay, I think we're recording again. Yep. So for this question, you've read through the wording of the question. That's buying t-shirts. We have data in the table. We have data in the scatter plot. We have a line of best fit with an equation. So for question number seven, the second number 7, the last one was number 8. Apparently I need to update this. Mean with the y-intercept. Volunteer, who can help us out? Green? You have thoughts?
Y-intercept is 5.
So that's the value, but what does it mean? Yeah. Zane, any thoughts what the y-intercept means? Yes, that's the 6.5. So you can see it here in the equation, and then we can see approximately where it is on the graph. Reading, you want another shot?
Is it how much the shirt costs and like after the sale cost per shirt at 0?
Except here, I think it's talking about buying shirts, isn't it? So P is the price per shirt and N is the number of shirts ordered. So he's buying shirts. So yeah, which is kind of a useless number because he's never going to order 0 shirts. But as you look at the scale on the x-axis, the numbers get pretty big, right? So up to the 800 here. So we could use the y-intercept as an approximation for if he was just buying 1 shirt. So if we were going to talk about the domain for this function, we'd probably say that our x, or our number of shirts, has to be greater than 0. It can't be 0, because he's not going to spend $6.50 on buying 0 shirts. So that's about what the price would be for 1 shirt. Okay, so let's write that down. $6.50 is about the price. Matt orders just 1 shirt. Matt, what do you do with these shirts?
Sell them.
You sell them. What kind of things do you put on them?
Whatever my customers really want. Basically, what's they really want. So if they really want one type of shirt that they really like, I'll produce that one. But if there's a new type of design, I guess, I'll put it up there.
Okay. Good to know. Thank you. That was a very quick on-the-spot answer. Well done. So my daughter likes doing crafty stuff. And so she buys shirts from Dollarama because they're cheaper. But you can get more colors at Michael's if you're going to do stuff on colored shirts. There you go. And Joel was in media studies for a semester, and they did some designs and iron-on stuff. So we need shirts for that. Okay, so what does the slope mean in this equation? So generally, we'd say, and I'll get to your answer in a moment, but we'd say that slope is a change in y over a change in x. So we need to think about what are the y values and the x values. So we have change in price per shirt over a change in the number of shirts. Bree, you have thoughts? So far, that's good. I like it. The change in price.
The price lowering for the more shirts you buy, the more.
Yeah, because this is given as a decimal number, it's 00, -0065. What does the negative sign tell us? So as we go from left to right, so if instead we thought, not the negative sign, but just what's happening on the graph here, as we go from left to right, our graph is going down in this direction. What does that mean? Price is going down. So as we go to the right, we're buying more shirts. So the more shirts we buy, the lower the price is per shirt. Okay? So that's what the negative sign means. And since we think of slope often as a fraction, if I just have it as a decimal, this is over 1. So what this means is the change in the number of shirts is just a 1. In other words, if I buy one more shirt, how does the price per shirt change? Well, it decreases by $0.0065. I think that was dollars, wasn't it? Yeah. So basically, it's like half a cent. But he's not buying in one shirt quantities, right? He's buying huge quantities. So this means, let's use a different color. Buying one more shirt will reduce the price per shirt by $0.0065 or 0.65 cents. Make sense? Goals that good? Make sense? Good? All right. Then we want to use his regression equation to extrapolate. And again, extrapolate means we're going outside the data we're given. Extrapolate the size of order necessary to achieve a price of $1 per shirt. So the equation was 8.0065 plus 6.5. So since we only have two variables here, we must be asked for either a P or an N. What do we ask for in this question? We're asked for a P, or we asked for a price? Or do we know the price? We know the price. Yeah. So we know we have this price of $1 per shirt. So that tells us the P value will be 1. And the N value is what we want to find. So we're just solving an equation. There we go. This is supposed to be an equal sign. And then we finish off dividing both sides by negative 0.0065. And I'm getting M value of about 846. There's 0.1, but I can't buy part of a shirt, so I'll just round to the nearest value.
You just answered my question. I was just going to ask if you round down, because you can't buy.
Yeah. Generally, we'll round to the nearest value. Sometimes the context of the question will require other rounding. When we get to a diploma exam, that will never be an issue. It'll always be rounding to the nearest value. So keep it simple for us that way. Okay, and we should explain the same words, because this number has meaning, right? So we can say, when Matt orders 846 shirts, the price should be about $1 per shirt. You'll notice in my wording these explanations, they're kind of vague. It's not absolute. It has to be this price. Because again, these are predictions. And so we can't be 100% sure. Chantel?
When we get a question, if we just like circle like the 846, would we get that wrong or right if we don't write like when that order?
If it's written response, then I'll want you to write an explanation.
Okay.
Tell me what the number means.
Okay.
Yeah. Because that's part of understanding the question, understanding what the number represents. Okay? Multiple choice numeric response, it won't be an issue. Okay. Last page is a summary. So this is just copied straight from the textbook. So it's on and off. We'll see. So you can take a minute to read through that, and then check your understanding. A couple questions for you to try. Just do your best to draw a line of best fit. Number 2, figure out the equation for each line. Our equations for B will probably be more similar. A, that's kind of hard. But do your best approximation to draw a line of best fit. And then is 301. Number 3 and 4, you can just do with a partner. Don't need to write stuff down. And then 6 and 7, those you can write down using a calculator. And that's as much as we'll do for today, I think. So really important that we understand how to do regressions on the calculator. The next section, if we just look ahead to that, what we're going to look at is doing quadratic and cubic regressions. So it's not necessarily linear. So just more regression stuff. Questions? Yes.
What makes it a linear? Because like when you look at the regression, is it because it has like just like two groups of values, like you have like the number of arc bytes and the floor space?
Not necessarily. For this one, do I ask you to do? Yep, I ask you to do a linear regression. What it has to do with is kind of how the data trends. And we're going to talk about that more in the next lesson, but we can talk about it now. I'll just turn this off. So if we have data that kind of goes like that, we'd say, oh, it could be linear. And if we have data that kind of goes more like that, we'll think, well, that's not linear, that's probably quadratic. But this one as well, a line could approximate it moderately well, so we could do a line sort of like that. But we could also say, well, what if I had a curve that went like this? Would that be a better approximation? Well, it probably would be, and in this case, it would be cubic. Okay? And so that's where the r-squared value comes in really helpful. Because you can try a linear regression, try a cubic regression, see what gives you a better r-squared value. Okay, but we'll get into that more tomorrow. Good. So, some work time today, and I can help you out as you need it. And we can end the recording. Yay! Goodbye, thanks for visiting.